bam, it's true. In this video, we're going to do more examples of the chain rule. Only this time, instead of just pure algebraic, we're going to incorporate some trig functions. So we have our 6 rules for derivation or derivatives of trig functions. We have derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared, the derivative of secant is secant times tangent, and finally the derivative of cosecant is negative cosecant times cotangent. However, you might have noticed as I just skimmed through those, I didn't exactly say everything these expressions say. Like, really we have here the derivative with respect to x of the sine of u. That's giving you a hint that there's going to be some kind of function going on inside here that we have to take care of with the chain rule. So we're going to have the derivative of the sine of u is equal to the cosine of u. Then, so we're going to find the derivative of that trig function, but then because we have another inside function, we're going to have to take that chain, extend it out, and find the derivative of that inside function. So we have y equals the tangent of 3x. Well, this 3x is our u, okay? That's our inside function. It's the tangent of something. Well, what is the derivative for tangent? How do you find that? Well, y prime is going to be the derivative of y is equal to, well, let's see here. The derivative of tangent is secant squared. So it's going to be the secant squared of 3x, but, you know, before where it was just like, well, what's the derivative of tangent? Secant squared x. But now we have an inside function of 3x, so we're going to have to find the derivative with respect to x of 3x. And of course, we're just learning this, so I'm showing you all the steps. A lot of you will just say, well, the derivative of 3x is equal to 3, and you'd be absolutely correct. So this becomes y prime is equal to, I'm going to go ahead and move this out front as a regular, as a coefficient, because that's what we're going to get. The derivative with respect to x of 3x is equal to 3. So we have 3 secant squared of 3x. Great. So now we got the secant of 3x squared minus 1. Same idea, just a different trig function and a little bit, just a tiny bit more going on inside that actual function. This might seem more like, oh, there actually is a u in there. The 3x, I mean, it is an inside function. We do need to take care of with the chain rule, but I could definitely see some students making a few more mistakes with this kind of problem. And then here you kind of clearly see we got a binomial. There's another function inside there. Both of these, of course, as you're seeing, require the chain rule. So y prime is equal to secant, now this is our u, so secant of 3x squared minus 1 times the, I don't need that parentheses, times tangent of 3x squared minus 1. And that's our u, so here's our u. Now we got to find the derivative of u, or the derivative with respect to x, of 3x squared minus 1. Well, the derivative of 3x squared, we're going to apply that power rule and get 6x. This is a constant. So, and I'm going to move that 6x out front, just y prime is equal to 6x secant of 3x squared minus 1 times the tangent of 3x squared again, minus 1. Let's go on to a couple more examples. Or not. Okay, I just wanted to always check my answers as I go. Talking, looking around, making sure I'm looking at the camera or whatever. Same thing happens in front of the class. Sometimes you just think, talk right, and it doesn't always quite work. You forget where you wanted to go. This may very well be a perfectly fine answer that your teacher will accept. However, sometimes you go in the back of the book and you look up your answers. It'd be nice if they're assigning you the odds so you can check your work. And you do some work properly here with the second example, but it doesn't look like what's in the back of the book. You might see this only in terms of sine and cosine. So let's go ahead and clear this off. And in case you need to, secant is 1 over cosine, and tangent is sine over cosine. So this can be rewritten as y prime is equal to 6x over 1 times, this is 1 over cosine, so 1 over cosine of 3x squared minus 1 times tangent is sine over cosine, so sine of 3x squared minus 1 over cosine of 3x squared minus 1. Now, oh, okay, so I've got 6x on top, a sine of 3x squared minus 1 on the top, and then we have cosine times cosine. Now, I can't just put these together and write cosine squared, except for the fact, of course, we do have the same angle, the same variable, the same inside function for both of these trig functions, so they will go together. And the final answer, another form of the final answer, is y prime is equal to 6x sine of 3x squared minus 1 over the cosine, let's see, cosine times cosine is cosine squared of, again, 3x squared minus 1. There wouldn't be much left to the problem if you were tempted to just cancel this out, but please, just in case you are, they do not. These are inside of a math function. This is inside the sine function. This is inside the cosine function. Now, let's get to those next few examples. So, we have our next three examples. We have y equals sine of 4 times x to the third. Cosine, just decided to switch the trig functions to get you to remember those. We have the cosine of 4x to the third, and then the cosine cubed, or to the third as well, times of 4x. Only not times, that's of. It's a math function. Okay, so all these look fairly similar, but they are going to work quite a bit different. That's because of where the parentheses are and where the power is. So, we have y equals sine of 4 times x to the third. See, it's just the sine of 4. X to the third is not inside the sine function because of the parentheses around the sine of 4. So this, we're not going to worry about actually, calculating that value, but that is a constant. So we're going to do the constant rule for finding derivatives, which is simply going to be y prime is equal to the sine of 4, that constant value, that there's a decimal, there's a fixed value for that, and a fixed answer, times the derivative with respect to x of x to the third. So we're not really doing the chain rule here at all. We're just recognizing that this is a constant and not getting confused because it's in the section of the chain rule and just going, okay, it's a constant, it's a derivative of x to the third power, so it's y prime is equal to sine of 4 times 3x squared. And if you'd like to make this look a little bit neater, you could say, you could take the 3 and move it out front, or actually the whole 3x squared if you want to write that first for some reason. 3x squared sine of 4, 3 sine of 4x squared, whatever you like. I like this way a little bit better because it doesn't, you won't maybe, especially if you're a little bit sloppy with your notation, think that that x is inside the actual sine function. It is just the sine of 4. And actually, my textbooks don't really do it very much, but I like writing parentheses around the angle measure that's in that trig function, so that doesn't happen. That little bit of confusion doesn't happen. Here we have y equals the cosine of 4x cubed, but it's not the sine function being cubed, it's just 4x. So we're going to go ahead and apply that power and get y is equal to, well, let's just go this way. That's going to give us y is equal to the cosine 4 cubed. 4 times 4 is 16, another 4 is 64, x cubed. Now we're going to find the derivative, and y prime is equal to the derivative of cosine is negative sine of 64x cubed times the derivative of the inside function. This is a u value here. This isn't just cosine of x, the cosine of 64x cubed. So we want to find the derivative with respect to x of 64x cubed. So this is just going to be applying the power rule. So we have, let's see here, we have y prime is equal to 64 times 3. 60 times 3 is 180, and 4 times 3 is 12. I lost my place there for a second. 60 times 3 is 180, and 4 times 3 is 12. So 180 and 12 is 192. And I'm going to go ahead and let that 192 float out front. So we're going to have the negative here and the 192. So negative 192. When we do the power rule, we reduce the exponent by 1. So that's going to be x squared. And that's the derivative of 64x cubed. Let's just take the sign of 64x cubed and stick it at the end there. All right? So, make sure I didn't do something silly. Perfect. All right. Moving on to the next example. Y equals cosine cubed of 4x. Now, this is the way we write it, but if you're using a calculator, maybe like a CAS calculator, make sure your answers are right, or just to help make this problem flow a little bit better, maybe make it look a little bit more like chain rule and remind you of that general power rule. We're going to take this cosine cubed and move it out, wrap this entire trig function with a set of parentheses, and move that 3 out there. Those are equivalent statements. So cosine of 4x cubed. You see how where the placement and the parentheses are different between the second and third example here. So we're going to have to apply the chain rule, the general power rule. We're going to take the, not power rule, general power rule. We're going to apply the chain rule. So we're going to take the 3, move it out front. So we got y prime is equal to 3 times the cosine of 4x. I'm not finding the derivative of cosine yet. I'm using the general power rule. I'm bringing this 3 out front. So it's going to be 3 times the cosine of 4x raised to the second power. Now I need to, this is my inside function. This is my something cubed. So this is my u. I got to find the derivative with respect to x of cosine of 4x. Okay, well the derivative of cosine is negative sine. So, chain rule. We got y prime is equal to 3 times cosine of 4x. Let's go ahead and write that power of 2. Let's go ahead and write that down here. So cosine squared of 4x. Derivative with respect to x of cosine is negative sine of 4x. And again, I don't have just a simple x in here. I've got 4x. I have another inside function. So now I'm going to have to apply the chain rule again. And just because we're learning derivative with respect to x of 4x. Okay, so the derivative with respect to x of 4x is going to be 4. So this is 4. This is all being multiplied together, so I'm going to let that 4 float out front and connect with the 3 and get y prime is equal to 4 times 3, which is 12, cosine squared of 4x. And what else have I not paid attention to yet? This is a positive 3. Here we have a negative 1 along with that 4. So this 12 needs to be negative because of this negative right here. So negative 12 cosine squared 4x. Now we have the negative out here, sine of 4x. And I think we're done with these examples. What else do we have here? I've got 3 more examples involving trig functions. They're rather long and tedious, and I think this video is long enough. That's your basic examples for using chain rule that involves trig functions. If you'd like to see 3 more advanced examples, we got one here that is going to involve the product rule and the chain rule. We've got many nested powers of the chain rule and square roots. So if you need to see more advanced examples, keep watching. If not, I'm Mr. True. Bam! Go do your homework.